Okay. So transport optimization or route optimization, right? Think about it, and it is not necessarily we have to like, though it is say one of the like big complex problem in optimization, right? So that NP or P hard problem, it is very difficult to optimally find a global solution. What does it mean? If I think about in this way, that Asian Paints kind of distributorship, right? Directly from factory, it is coming to the retailers. If you have 20 factories or 10 factories or 5 factories, and you have to serve, let's say 70,000 retailers, right, across India, how many trucks will be required? Which route they should take? Uh, any FMCG company, they every day in day out they want to solve this problem. If I have a plant and from plant it will go to 300 distributors, right? How many trucks I require every day? Which route they should take, right? Or it can be as simple as your newspaper person or the right now I think most of us are not buying the physical newspaper, but earlier if you see then for that person he also has to like mentally find out that which route he should take so that optimally he can save time, right? But similarly, a person who is supplying milk to your houses, right, different houses in the morning, he also has to optimize that, okay, which house he should go first, then which house next, because by the time he reach last house, he will complete whatever delivery and he will return to the his own house, right? So this is why this route optimization is also known as milk run. Part of the problem is also known as milk run, right? Routing optimization addresses the optimization of travel path in a network structure. Once we have defined that, okay, we have this factory here, we have this distribution center here. Now what we have to decide, the trucks or the vehicles which we have, which path they will take, right? Whether they will go to first this distribution center, from there to the other customer, how many customers they can cover, right? So this is where our route optimization or transportation optimization comes into picture, right? We can have a restriction to how many fleet size, how many transportation vehicles we have, right? Vehicle capacity, each vehicle, anyhow that we are capacity, like how many products or how many components the vehicle can carry, time windows, right? So this is something again essential, right? It has to reach, like think about a newspaper or a milk vendor. By morning, this time they should be able to deliver, right? If they are not able to deliver, they have to appoint another person parallelly, right? Same thing with your suppliers also, right? Distributor also. They have to, your truck should reach within 3 days or 5 days, right? That is something essential you have to think about customer service time or the customer lead time, right? So in particular, we are looking for the shortest or quickest connections between a given start location and given destination location, right? So if I have a distribution center here, and these are the customers, and each customer might have a different time window, right? This customer only will be available 4 to 9 p.m. Amazon also does that, right? That they are looking for, like, if you see in that Amazon window, you can put that on which day you want to receive your parcels, whether it will be available on Saturday, Sunday, right? If you are not there, where that parcel should be delivered, with the neighbor's house or with the security guard. They also, in a way, they're doing this kind of transportation optimization for their warehouses when the delivery persons are going, right? Because the same delivery vehicle will be delivering at least 20 or 30 apartment or 20 or 30 houses, right? So how to optimize that? Which route they should take, and which customer they should go first, and which customer they should go next. So all this route means connecting the path between customers, right? These two locations are both part of a network, but there is no direct connection available between them. Instead, it is necessary to determine a sequence of concatenated direct connections between intermediately passed connection point that connects the start and terminus location. These kind of problems also can be applied in a airport, like kind of routing optimization, not airport, this airline optimization, right? So if I have only three, for that, let's say Indigo or the right now Air India being taken over by Tata, right? So let's say I have 100 airline, 100 this kind of aircrafts, right? And I have this many destinations to cover. I cannot have like more than 100. I have maximum 100, and I'm not going to spend more than that. Then within that 100, with that capacity of 100 aircrafts, how can I cover all those paths? Right. So that's why if you see most of this path, if I want to go to from Bhubaneswar to Pune or maybe Bhubaneswar to some place, I might not have a direct flight, right? So that is where your transport optimization happens. So I'll connect all of those people who want to go from Bhubaneswar to some, let's say, place from Pune or maybe to like kind of Manali or something, some area like which is Leh, Ladakh. So what will happen? All of them will be transported to from Delhi another flight to Leh, right? So this is where you are optimizing your route, right? The airline automatically saying, okay, this path is available. We do not have a direct flight from A to B. We have from A to C and C to B, right? So connecting the path. That is also one set of problems which can be solved through this transport optimization, right? Uh, so what are the changes we have to make? I'll tell you, and I'll also have written in your class exercise. So let us quickly jump into the software. Where is this? I want to see here. Is the screen visible to all of you? Is the logistics screen visible to all of you?
Yes, sir.
Okay. So what you have to do, if you have done this network optimization in your class exercise, right? You have already filled in all the details, right? Like in our last class, right? Just right click it, create a copy as TO. TO means transport optimization, NO means network optimization, GFA greenfield analysis, SIMA simulation. We have covered GFA simulation, then network optimization. Today we are going to cover something called transportation optimization, right? So right click on this data convert. I have already done it, so I'm not doing it again. Just create a copy as TO. So if you go to here, so this class exercise 2 TO will be available there, right? So this is the data already which is available in your network optimization. There are few changes need to be made. Go to the your first you go to this path. Okay. So in path, what we are going to do, if you see, you will have only these two options, from factory to distribution center, from distribution center to customer, right? So let us try to understand what actually we are doing. So we have four customers, right? So this is the same data what we had in your network optimization in previous class. We have four customers in Delhi, Mumbai, Chennai, and Kolkata. I have put two factories. One is Nagpur, another is Visakhapatnam. Okay, Visakhapatnam and Nagpur. And I have options of two distribution centers. So this is in Aurangabad and this is in Cuttack, right? So now the question is, so only challenge here is in this non-commercial or academic version, the transportation optimization will not consider the factory, right? So that is the only problem. Otherwise, it will consider the path between distribution center to the customer. Now, let's say that is the problem I want to solve. So my vehicles are moving from distribution center to customers. Now the point is, if I have the option that okay, in one single truck or a big truck or big vehicle, I can send. Let's say there is a requirement from Chennai and Kolkata, or there is a requirement from Mumbai and Delhi, and my vehicles are starting from Cuttack. Can they move first to Kolkata, then to Delhi, then come to the milk distribution happens in a city? So the person who is carrying milk, he will be carrying 20 liter or 15 liter of milk. So every house, wherever 1 liter, 2 liter, 3 liter, like this, as per the defined what is the requirement from customer, he delivers the milk and return to the parent location, the his house, right? Same situation here. If there are requirements from Kolkata, Delhi, and Mumbai, can my vehicle, can I send a single vehicle? If obviously capacity has to be defined, how many it can maximum like kind of items or components or product it can carry. From here, it will go and reach Kolkata, deliver there, then go to the other location, then go to the other location, right? So this is nothing but I am trying to find my max, which route it should take. Either it should go like this, or it should first go to, let's say, this Chennai, then go to Mumbai, then Delhi. So there are multiple options. Now what I can say, what can I put some constraint? What is the maximum path it can cover? So it is not something a very big vehicle that okay, it will go up to like how many kilometers. So if I can define how many maximum kilometers it can travel, similarly how many maximum customers it can serve. So if I define that okay, no, anytime my truck is moving, maximum 2 customers it can serve. So it only will go to this or this to this, or going this again come back to this, right? Going to Kolkata, then come back to Chennai, that is one path, or Kolkata, Delhi one path, or Kolkata, Mumbai one path, or Delhi, Chennai one path. So there are different paths are coming, right? Depending upon what are the constraints I'm putting on my path. Now my question is, which will be my optimal route or optimal path my vehicle should take so that the delivery is happening, right? So this is what we will be looking into here in this problem. Transport optimization means route optimization, where you are trying to save money. Save money, obviously save time, save effort in terms of which transportation path or route you are taking. There are two limitations here in this software. One limitation obviously is we are not actually using the road, because this is academic version, so we do not know. So it is always going to take a straight path between two locations, right? Which might not be true. If it is moving from Kolkata to Chennai, there will be a proper highway route, right? It is not that it will be covering through this water, right? So that is one big problem. But again, at least it will help us in our understanding. Second problem is that in the non-commercial version, factory is not included. Factory data is not included, right? So those are the two challenges. Now knowing that, what else we need to do? We copied the network optimization path into this transport optimization. We have these two paths already: factory to distribution center, from distribution center to customer, right? What we have to add? We have to add one more path from customers to customer, then another path from customer to DC. So why we are doing this? Right now in our network optimization, what is our path? From factory to distribution center to customer, right? But what we are trying to do, the vehicle will go from distribution center to customer, from customer again it will come back to distribution center, right? So we are trying to close the loop. So any truck, there is an option that from distribution center it will go to a customer, from customer to customer. So movement might happen from customers to customer, again from customer to distribution center. So we are trying to close the loop. Earlier, what used to happen? We have only two paths: from factory to distribution center, from distribution center to customer. These are the first two paths which is available to you. Now we are trying to close the loop by doing customers to customer. So we'll add one path from customers to customer, another from customer to distribution center. Right. So these are the additional two paths we have to add in your transport optimization. Anybody having any doubt why we are adding these two paths? Okay, so once you add this, one more change you have to do. In our case, earlier cost calculation was something like distance based with fixed cost. Anytime a transportation is happening, there is a fixed cost plus per kilometer there is a charge 10 rupees, then fixed cost by 1000. That we need to change it distance based with cost per stop. Because now what we are telling, whenever the transportation is happening from a distribution center, it can go to multiple customers. So now we're not just telling it is only one fixed cost. So anytime there is a stop, there will be some cost associated with the transporter is going to charge, right? So this is where we are changing distance based with cost per stop. Anytime because the vehicle is moving, let's say it will go to Kolkata, it will stay there for 4 or 5 hours, right? So that is a waiting period. For that transporter is going to charge. Then once it goes to Delhi, there might be certain waiting period. 5-6 hours it has to wait, unloading will happen, then only it can go to the next destination, right? So he's charging for each stop, right? Earlier what used to happen? One transportation fixed cost 1000 rupees plus per kilometer some effort or some money he was charging, right? So that is one change you have to do. So all the cost calculation will happen distance based with cost per stop. Then change this cost calculation. Variable cost is 10. This is 10 rupees per kilometer. Though it is not written, variable cost 10 rupees per kilometer. This is cost per stop 1000 rupees, right? So make those changes for all those. Then vehicle type, make sure that you are choosing that vehicle type for all the 4 locations. So we have added a truck as our vehicle and we are adding in all those 4 paths, right? So that is one change you have to do. Then go to vehicle type, okay, speed limit. So there is no change. Capacity 20, capacity if you want, you can increase this, but let us not change this. What else we have to do? We change, yeah, I think that is only sourcing is there. Product, I have 4 product group, period, path. I think only the change in path will happen. Groups, demand, already there. I'm not making any changes. DC and factories, okay. DC and factories. Okay, make sure that these all are considered. Right? Put all of them as consider. Uh, demand anyhow, I'm not making any changes. Customers, I have 4 customers. So click on data, right? Then PO experiment. Here make sure that vehicle types is chosen as whatever vehicle type, whatever the vehicle name you have given. And this is what travel segment limit, right? So if it is a vehicle is moving, right, what is the maximum distance it should go, right? Then return path. Obviously, return path will be the same as your segment limit, right? So I'm putting a limit because if I say that my vehicle can travel from, let's say, my distribution center from Cuttack to Kolkata, from Kolkata to Delhi, from Delhi to Mumbai. So I have to give a length. So it will be for you, it will be given 500, make it 5,000, right? So that you are allowing your vehicle in a single route or in a single path to cover multiple cities, right? If it is within a state, obviously 500 or 800 is good enough, right? But when I'm telling it is to national level, right? It is going at different metro cities, right? So that's why I'm putting that segment limit little higher. Currency distance will remain same. What else? Okay, so here what you change, you will do lot of 3 iterations. So I have only 4 customers, right? So I'll first check with if maximum customers in a route is 2. That means the maximum customers the vehicles can serve can go to is 2. So let us try with that first. So TO experiment, run the experiment. Okay, so Nagpur is one my factory and Visakhapatnam is one factory. So this error you will find, right? So don't worry about that. So what is my generated path? So just let me expand. So one of my path is Aurangabad to Aurangabad will serve Delhi and Kolkata. Aurangabad is going to serve Mumbai and Chennai, right? So this is the total cost of transportation, 65,270 rupees. Other option is Cuttack distribution center will serve Kolkata and Delhi, KND, and Cuttack will going to serve Chennai and Mumbai. So total cost is 69,667, right? So this will help to understand us which distribution center we should use to transport our product to which customers, right? So total overall cost for Aurangabad is coming less, right? So if I have an option, so I'll operate Aurangabad distribution center and send my like 2 trucks, one from Aurangabad to Delhi and Kolkata and another to Mumbai and Chennai, right? So this is where if I'm telling that maximum customers in a route is 2, right? So this I'll rename, I'll say that the result 2 customers, okay? Then I'll change it here, I'll make it 3 customers, okay? So that means in a route, in a path, and the truck can actually serve 3 customers at a point of time. Okay, okay. So this error message you will be looking into. See if I'm able to serve 3 customers. So Aurangabad DC, Chennai, Kolkata, Delhi, right? So total is 49,957. Mumbai, another truck, 7,541. Total cost is 57,499. Cuttack, Kolkata, 57, total cost is 57,793. Right. So in this case, again, still Aurangabad DC is my preferred distribution center, right? To transport to, again, two trucks, one going to Mumbai, one going to Chennai, covering Chennai, Kolkata, and Delhi, right? So this is when I do, I'll make change. So this is my three customer solution. So that means in a path I'm covering three customers. Then last one I'll run telling maximum customers in a route is 4. Okay. So see, if I have the option, which again becomes a problem, right? Though my cost is gradually reducing, but think about customer lead time, right? Some customers, so here I have not changed the lead time. The lead time is 30 days, but none of the customers will have a 30 days lead time. Some customers might say that whenever I put an order, I should get the vehicle within 7 days or 15 days, right? So because I'm sending only one vehicle and that vehicle will cover all the path, it will take a lot of some customers who are like in a later far distance, they'll get the vehicles at a later date, right? So this is my, so here what happens actually Cuttack is becoming lower, 53,716. So these results I will change it to Cuttack 3-4 customers. So these are the three different types. So by limiting how many customers my vehicle can serve at one point of time, so these are the few results of my path or route optimization I get, right? I can also see my optimization path of what is the route. If I go here to customers, what is the route? So which is first one? So Aurangabad DC, it will first go to Delhi, then will come to Kolkata, then return to Aurangabad DC. So Mumbai, which one will come? Obviously from Aurangabad to Mumbai first, then Chennai, come back to again Aurangabad. Then this is another path, this is another path. This also I can look into three customer solution. Aurangabad, this is Chennai, then Kolkata, then Delhi. This is one path. Another path is only to Mumbai. From Cuttack, one is to Kolkata, other is to first going to Delhi, then going to Mumbai, then going to Chennai. Right. So like that, I can four customers. Obviously, I have only Aurangabad. First, it will go to Delhi, Kolkata, Chennai, then Mumbai. For Cuttack, Kolkata, Delhi. So basically, for closest first, right? So whichever. So when I'm talking about Aurangabad, it is first going to which one? Delhi. So it is not going to the closest one. So it is my. So this is factories. Let me just see demand. Sourcing. Closest dynamic I have put dynamic sources, so it will change. If I say closed fixed source, it will happen. Okay, still it is taking. Delhi is the first location, Kolkata is the second, Chennai is the third location, fourth. Okay, so it is not taking that way. So let me change it back. Product groups, sourcing, customer store from DC, close dynamics. Okay, so these are the kind of experiment you can run, which path your kind of which path your trucks or the vehicles should take to transport material or transport products, then you can compare the result. So if I'm having two customers, so at a time I can only maximum serve two customers. My total cost from Aurangabad DC is 65,000. Cuttack DC is 69,000. If I have three customers, it is coming down to 57,000. This is 57,793. If I can at a time serve four customers in one route, sorry, it is again further from 57, it is coming down to 54,917. This is becoming 53,716. When I have the option of serving all four customers at one path in a single route, actually Cuttack DC is becoming more profitable, right, for one path, right? So this is about your this is your transportation optimization. So anybody having any doubt how to run the transportation optimization? Okay, so if not, that's all for today. Next class you have a holiday. 21st we'll discuss something on supply chain risk management, right? How to manage risks like COVID or earthquake or any natural calamities or anything like let's say plant gets shut down, right? What happens, right? How to manage or how to forecast, anticipate those risks, and how to plan for that, right? So that's all for today. Anybody having any last question? Okay. So remember that your project due date is 21st, I guess. So please complete your project and submit by 21st of April. Chalo, take care.